Example number 5, another special case because there's a natural logarithm involved. Now note the entire numerator here is being raised to the 5th power. Okay, so here's the process. We should have the understanding that the derivative of the natural logarithm of x is equal to 1 over x. Well, note there's an x here in the denominator of this given integral. So here's what we need to do. We're going to let u be equal to the natural logarithm of x. Why are we doing this? Well, because now when we take the derivative of both sides, we get this. The derivative of u is 1 du, or just du, and that's going to be equal to the derivative of this. In terms of x, the derivative of this is 1 over x with respect to x. So this 1 over x is in the given integral, because this really means 1 divided by x. There's an understood 1 here. All right, so let's rewrite this thing. So now, using this information to rewrite this integral in terms of u, we would get what? We would get the integral of u to the 5th with respect to u. Note, this du right here takes care of the 1 over x and the dx. So this is correct. We're in good shape. Now all we have to do is evaluate this thing. So we do what? We have u to the 5 plus 1, or 6. Divide by that new exponent, then put your plus c because it's indefinite. Now, what's u really the same as? Well, it's the same as the natural logarithm of u. Well, excuse me, u is the same as the natural logarithm of x. So let's make the change. This u becomes the natural logarithm of x. All to the 6th power, all over 6 plus c. You can leave it just like this. Example number 6. This is our last example we're going to be looking at here from section 11.2. This one is probably our most challenging type because of everything going on. So notice in this case we have a sum, a sum of two different expressions. So one of the properties of integration allows us to do this. Since there's nothing else I can do, if I were to leave it like this, there's really nothing I can do to take the integral of it as it is written. So what I'm going to end up doing is rewriting this single integral as the sum of two integrals. So that would look like this. And now, because I'm rewriting this single integral as a sum of two different integrals, I'm now able to use substitution twice to ultimately evaluate this indefinite integral. So looking at the first part here, here's what I'm going to do. So the first integral, what I'm going to do is I'm going to let u be equal to negative x squared. And again, this negative x squared is 1 degree greater than some other part, some other term that's involved with this integral. Okay, so then I take the derivative of both sides, and that would give me a negative 2x dx. Well, note in this integral, I don't have a negative 2 in front of this x, like I do here. So, as per usual, we're going to divide both sides by a negative 2. Canceling that out. Now we have what we want. We have an x dx. X dx. Okay, so this would generate what? Well, this part, the numerical part here in front of du, again, it really means negative 1/2 times du. You're going to write down the negative 1/2. Whatever the numerical value is right here, the numerical coefficient, write that down before you put your integral symbol. Okay, now what goes in the integral? Well, it's going to be e to the u. That's going to be part of it. E to the u, why? Well, e to the u. U is negative x squared, so that makes sense. Then make sure you put your du here. Again, why are we doing this? Du is exactly the same as x dx. There's your x, there's your dx. So this whole thing means x dx. Okay, I'm going to go ahead and evaluate this. I would get negative 1/2 e to the u. We already know that, so let's go ahead and make the substitution. U is the same as negative x squared. And I'm going to leave it like that for now, because remember, we have to still worry about this integral as well. Okay, so part 2 here, based upon this integral. Part 2 would be to let, I'll use a different letter, let v be equal to ex plus 3. So if I do that, dv, the derivative of this left side, would be equal to e to the x times dx. All right, so let's look at this integral and what we have here. So v, we have this taken care of in terms of v. It's e to the x plus 3. And then dv, that takes care of all this. dv is equal to e to the x times dx. So everything has been accounted for. We are good to go. Let's rewrite it. So the rewrite would be the integral of dv all over v. Okay, so dv in the numerator, and then v, that's in the denominator. And we looked at one of these earlier, so I'm just going to cut to the chase. The integral of dv over v is the same as the integral of 1 over v dv, which will result in the what? In the natural logarithm of the absolute value of v. In this case, v is equal to e to the x plus 3. All right. Woo! Finally, putting this all together. Because remember, it's going to be equal to this plus this. So therefore, our final answer is negative 1/2 e to the negative x squared plus the natural logarithm of the absolute value of e to the x plus 3 plus c, because it's indefinite. Wasn't that fun? Have a good day.